So, hi everyone. I'm Jimena Rodriguez from the Institute of Astrophysics of La Plata, and today I will talk about the internal distribution of the stars in some star clusters in the Magellanic Cloud. This is a work that we are doing as part of the VISCACHA project. Here are all the authors involved in this work. And the motivation to study the internal distribution of the stars in the clusters, that is what we call the internal structure, is because it can provide us important information about the formation of the cluster and its dynamical evolution. It is observed in young stellar clusters that they present a fractal of subcluster distribution of the stars. Numerical simulation and observational results suggest that this fractality is erased with time, giving rise to a more centrally concentrated distribution with a radial gradient. So one of the objectives is to find out more about the time scale in which the star cluster lost their initial fractal structure, and also the dependence of the dynamical evolution of the cluster with the environment. So here we can see some of the VISCACHA cluster studies in this work. They present very different ages. So as I mentioned before, we are using data of the VISCACHA survey, VISCACHA photometric survey of cluster in the Magellanic Cloud. In this work, we use data from the data release 1, that it has 83 star clusters located in the periphery of the Magellanic Cloud. Here we can see the distribution of the study clusters. They were observed with the SOAR telescope plus adaptive optics. We have 51 clusters in the Large Magellanic Cloud with distance to its center between 4.5 and 6.5 kiloparsec, and 32 clusters in the Small Magellanic Cloud with distance from its center between 1 and 6.5 kiloparsec. And the cluster study span a wide range of age between 40 million years and 5.5 Xi years. So to study the internal distribution of the star, we use the minimum spanning tree method, that basically spanning tree. A minimum spanning tree is the shortest network of straight lines that connect all the points in the distribution without closed loops. Here are some of the minimum spanning tree for the study cluster. We can see that they present a very different concentration of the star. And from this minimum spanning tree, we derive two quantities, m, which is the mean length of the connected segment normalized by the cluster area, and s, which is the mean separation of the star normalized by the cluster radius. And with these two quantities, we derive the Q parameter. That this parameter was introduced by Cartwright and Whitworth in 2004 to study the internal distribution of the star in a cluster. And it helps to distinguish between a fractal distribution of point, in the case that this value is lower than 0.8, an homogeneous distribution, it is around 0.8, and we have a radial distribution if this value is bigger. So before applying the minimum spanning tree, we filter the data. We only take data with B magnitude lower than 22, and errors in magnitude B and I lower than 0.1. So, for example, here we only keep the data in black, and we use different values for the cluster radius. We use 2 core radius, 2.5 core radius, and 3 core radius for the value of the cluster radius. Here are the value of Q obtained using 2.5 core radius. The red line is the limited value of 0.8. We can see that most of the study cluster present bigger values of Q, so it means that they have an homogeneous distribution or a radial concentration of star, a radial distribution of star. If I compare what we obtained with 2.5 core radius, that is the previous slide, with the other study radius, we see the difference obtained in the Q value is very small. It is in general lower than 0.05. So in the next slide, I will show you only the values, the result obtained with 2.5 core radius, but we observe the same trends and results with the other values. Here the spatial distribution of the cluster, where the color indicate the Q value. Here are indicated different regions. We have these 4 regions: Large Magellanic Cloud, and here the cluster in the bridge, West Halo, and Counter Bridge. But from here, we can see that it seems that the cluster more distant from the center of each galaxy have a bigger value of Q. So we study how change Q with the projected angular distance to the center of each galaxy, and you will see that it seems to be a positive trend between these two quantities. Perhaps it's more evident, a bit more evident in the Large Magellanic Cloud. But well, we have a very small range in distance, so we need more cluster more near to the center to continue study this trend. Here is the MS diagram. In the left, we have the diagram for the study clusters. The red line are the Q value of 0.8, and the other green lines are other Q values. Here, in color, are indicated the ages of the cluster for those that we have this quantity. And in the right, we have, the MS diagram obtained from numerical model. The red point correspond to cluster with radial distribution. The blue points are cluster with fractal distribution. The direction of the arrow indicate the direction in which cluster are more centrally concentrated. So if we compare these two diagrams, we can see that our cluster, our study cluster, follow the trend for that cluster that have a radial distribution of the star. And again, it seems that more all other cluster are in this region, which correspond to cluster with bigger central concentration of star. So we study how change this Q with age, but as not all clusters evolve dynamically in the same time, because the dynamical evolution of a cluster depends on several factors. We take the dynamical age, which is defined as the age of the cluster the radio between the edge of the cluster and the crossing time. Here, the size of the point corresponds to the number of stars in each cluster. And here, it seems to be a positive trend that indicate that more able clusters have larger value of Q. Sanchez and Alfaro in 2009 found a similar trend, a positive trend for cluster in the Milky Way. They use a different indicator for the dynamical age, but the idea is the same. And this result was also suggested by several numerical models. So this is a work in progress, but I left here our preliminary conclusions that most of the study cluster present a radial or homogeneous distribution to start. We observed a higher value of Q for cluster more distant from the center of each galaxy. And also our results suggest that more dynamically able clusters seem to have large value of Q, confirming the result from the Sanchez and Alfaro for the Milky Way, and also of the result of several numerical simulations. So thank you very much for your attention.
Thank you. Thank you very much. Are questions here from the audience or from the chat? Gabriel, go ahead.
Hi. Yes. How did you handle the presence? Can you hear me?
Yes.
How did you handle the presence of binary systems?
Here, do you ask for binary systems? I don't. Well.
Yes.
We don't take account binary system here.
And do you expect that they can affect the Q parameter?
Sorry?
Do you expect that the presence of binary systems can affect the estimation of the Q parameter?
We don't think so, because we estimate the Q parameter in simulation, adding several start or very near start. We don't see a big change, but of course we have to explore more about it.
Okay, thank you very much.
Hi, very
Hi.
nice talk. You presented a plot with different symbols for different components of the galaxy, with halo, reach, etc. I couldn't see it very well. No. With the different with the different components, with halo.
Yes, it was here. This one with halo contribution.
No. Yes, this one.
Sorry.
Is there any correlation? I don't see. Is there any correlation with the different components?
We don't see any correlation. We are continue studying that, but no, we separate here between the different regions, but we don't see any correlation in special.
I wanted to see it again because I couldn't see it before.
Yeah, perhaps here for the Large Magellanic Cloud, the cluster in the XI FoF groups are more follow better this trend, but it's the only thing that we can say.
Thank you. Very interesting.